Hey everyone, welcome to this explainer. Today, we're jumping right into something absolutely crucial, the massive global shift from our current linear waste system to what's known as a circular economy. Let's get right into it.
So, let's talk about this number, 3.4 billion. It's a pretty jarring projection from the World Bank. Basically, if we keep going the way we are, global municipal solid waste is going to hit 3.4 billion tons by the year 2050. I mean, to put that into perspective, that's a massive, massive jump from the 2.01 billion tons we generated back in 2016. Clearly, our traditional waste management approaches, they're just not cutting it anymore.
And honestly, this staggering number is the direct result of our traditional linear economy. For decades, we've operated on a strict take, make, and dispose loop. We extract resources, mass-produce goods, and then, at the end of the line, we just throw them away. It's like a one-way street straight to the landfill. And this model is a huge contributor to severe resource depletion and global pollution, which is fundamentally threatening our land, our marine environments, and public health as a whole.
So here's our roadmap for today's explainer. We'll start with the linear crisis, introduce the circular solution, do a deep dive into organics and plastics, and finally, look at the key drivers of success.
All right, let's kick things off with Section 1, the linear crisis, a system of containment.
Now, there is a really stark contrast in system design here. It's kind of fascinating. Traditional landfills, well, they are engineered purely to isolate and contain waste. They basically just compact our trash into super dense layers and seal it all off from air and moisture just to control the risk. But on the flip side, resource recovery actively aims to transform and reuse those materials. It completely shifts them from being this long-term liability hidden in the ground into a valuable recovered asset.
Which brings us nicely to Section 2, the circular solution, a system of transformation.
And this is the heart of the solution, a closed-loop system. The whole idea is designed to keep products, components, and materials at their absolute highest utility for as long as possible. The main goal here is to establish an economy that is restorative and regenerative by design. Basically, we want to decouple economic growth from environmental harm, literally minimizing waste right from the drawing board.
So the crucial takeaway here is that we have to actively, and I mean actively, replace those old take-make-dispose habits with strategies that reduce, reuse, recycle, and regenerate natural systems. This means extending product life cycles through remanufacturing, encouraging models where you pay for a product as a service, and really just shifting our entire mindset to ensure natural resources are optimized and kept in use continuously.
Moving right along to Section 3, Organics. Compost versus landfill.
Okay, think about what happens to your food scraps. If you toss an apple core into a landfill, the complete lack of oxygen there suppresses the helpful aerobic microbes. Instead, you get this incredibly slow anaerobic decomposition. And that produces methane, which is a super potent greenhouse gas, and it locks up valuable nutrients like nitrogen and carbon forever. No good. But composting works the exact opposite way. It relies on carefully managed biological conditions, using oxygen-loving microbes to stabilize the organic matter. This shifts the whole chemical reaction to release carbon dioxide instead of methane, and it actually returns those valuable nutrients back to the soil to support new plant growth. It really proves that location entirely decides the behavior of your waste.
Actually, let's bust a quick myth right here, because this is a big one. You know those compostable plastics you see everywhere now? Well, throwing them into a normal landfill ruins their design completely. See, in a proper commercial composting facility, these materials break down safely. But landfills, like we talked about, isolate waste to prioritize containment. They completely lack the airflow and microbial diversity needed for things to decompose. Because of that, those quote-unquote compostable products will just persist for years and can even generate methane as they slowly degrade. So slapping a label on a cup doesn't change the outcome. Routing the waste properly is what actually determines its performance.
Let's shift gears a bit for Section 4, the plastics journey, technical cycles.
Now, did you know that in 2022 alone, over 5 billion pounds of plastic packaging were recycled in the US? 5 billion. It's this massive, complex, reverse supply chain that literally begins right in millions of our households. And moving this massive volume around drives jobs, creates revenue, reduces our need to extract raw natural resources, and significantly lowers greenhouse gas emissions. It's a huge step pushing the country closer to a true circular economy.
But here is the catch. This entire massive supply chain relies entirely on you and me putting the right things in the bin.
The system is specifically engineered to recover clean number 1 PET bottles, number 2 HDPE bottles, and number 5 PP containers. You've got to empty out any remaining food or product. Seriously, nobody at the plant wants your leftover soup. And you need to keep the caps on. And just as crucially, keep out contaminants like thin plastic grocery bags or flexible films. Those things wrap around the gears and completely disrupt the sorting and processing facilities.
This whole journey relies on 3 absolutely critical steps: your household sorting, the collection and sortation, and finally, processing and recovery. Because organic contamination or the wrong types of plastic can completely derail this chain. Routing materials properly is what turns your everyday chore of tossing a bottle into a vital economic driver for sustainable manufacturing. Again, execution decides the outcome.
Finally, let's wrap up with Section 5, Drivers of Success, Building the Future.
So, looking at the numbers, circular strategies are already seeing massive success across various sectors. The data is incredibly promising. For instance, agriculture is seeing a massive 60% reduction in waste, largely through composting and bio-based loops. Manufacturing is down by 50% thanks to industrial symbiosis, which is essentially just a fancy way of saying they are converting one company's waste into another company's raw materials. And the automotive sector? They've achieved a 45% reduction just through remanufacturing and reusing parts. Real game-changer stuff.
However, we have to be realistic. Severe barriers to adoption definitely still remain. A 65% lack of infrastructure, along with high initial investment costs, are severely hindering progress, especially in developing regions or for smaller-scale businesses. Plus, regulatory gaps and low consumer awareness act as chronic, ongoing barriers. Overcoming all of this is going to require a serious multi-stakeholder strategy. We're talking a combination of government policy, financial incentives, and technological innovation to truly unlock a resilient, zero-waste future.
So, as we conclude this explainer today, I want to leave you with this thought. Knowing that routing determines performance, how will you handle the waste in your hands today? When you look at your curbside bin, will your everyday choices build a mountain of isolated waste, or will they fuel a regenerated circular future? The power to decouple economic growth from environmental harm literally starts right at our fingertips. Think about that the next time you hold a piece of plastic. Thanks so much for joining me on this deep dive into the circular economy, and I'll catch you in the next explainer.